Alright, I'm going to try to quantify exactly how much openings matter in chess. Now, this is a complicated question that depends on various factors, blah blah blah, I don't care about that. I just want to make enough simplifying assumptions so that we can easily calculate it. So here's what we're going to do. We're going to assume that you are a completely average Lie chess player playing against other completely average Lie chess players. What I mean by this is that, for example, if the Lie chess database shows a position has a 60% win rate for white, a 30% win rate for black, and a 10% draw rate, then we're going to assume that your games that reach that position have the exact same distribution. So if you're white, you have a 50% chance of winning, a 46% chance of losing, and a 4% chance of drawing, for an expected score of 0.52. However, if you make the decision to play one knight f3 in every single one of your games, then as white you have a 51% chance of winning, a 44% chance of losing, and a 5% chance of drawing, for an expected score of 0.535. So this one decision single-handedly raised your expected score as white by around 1.5%. Not bad. Similarly, if you're black, your expected score is 0.48. However, you can improve this as well by making the decision to always respond to one e4 with c6. See, in the scenario where white plays e4, black has an expected score of 0.49, but if black plays c6, the Caro-Kann, they have an expected score of 0.51. So this decision can raise your expected score as black by 2% multiplied by the probability of white playing e4, which is 59%. This comes out to 1.2%, which again, is not bad for one decision. Putting these two decisions together, you get an expected score of 0.535 as white and 0.492 as black, for a final average of 0.5135. And if we plug this into the ELO expected score formula, we see that this is equivalent to gaining 9.4 ELO. The question is, if we keep on making the opening decisions that increase our expected score the most, how much more ELO can we gain? Well, one thing's for sure, I need a better system than manually making moves on the Lie chess board and plugging these percentages into the Windows calculator. Fortunately, the API that provides all this data is publicly available and it's pretty easy to use. They don't say exactly how often you're allowed to query it, but in practice I found that I could make about one request per second indefinitely without getting rate limited. Alright, here's the plan. At any given point in this decision-making process, we have a particular opening repertoire that we've committed to. Once we've decided on a move in a particular position, we never reconsider it. Sure, if we look farther ahead, we may find that a move we discounted earlier can actually lead to a better strategy, but especially with the one API request per second limitation, we gotta be practical here. The first step is to list out all of our opponent's possible responses to our repertoire, except the ones that we already know how to deal with. Next, we list all of our possible responses to those responses. For each of those choices, we calculate how much it would improve our expected score with the following formula, where old score is our expected score after the opponent move according to Lie chess, new score is our expected score after our response to the opponent move according to Lie chess, and p is the probability of our opponent playing into this line, again, according to Lie chess. Next, we add the response with the highest delta score into our repertoire, and finally, we repeat the process. One thing I should mention is that, to avoid small sample size issues, I'm only considering moves that have been played at least 100 times.